Hi, my name is Melissa, and I will be going over impulse force. Impulse is the product of force and the time over which said force is acting, therefore measuring the effect of that force over the time that it is applied. This also creates a change in the velocity of the object that this force is being applied to. The formula for finding impulse force is J, which is the symbol for impulse force, is equal to force times change in time. The units for impulse force are Newton seconds, or Newton's times seconds. Another equation that is important when talking about impulse force is P equals mv, or momentum is equal to mass times velocity. The formulas for momentum and impulse force can be related using the equations F equals ma, or force is equal to mass times acceleration, and A is equal to change in v over change in t, or acceleration is equal to change in velocity over change in time. The variable a in the equation F equals ma can be replaced by the change in velocity over change in time, leaving us with the formula force is equal to mass times change in velocity over change in time. Simplifying this equation by multiplying each side by change in time, we are left with force times change in time is equal to mass times change in velocity. This shows us that the relationship between the impulse force and the change in momentum of an object is equal to each other. In other words, the force times the amount of time that the force is applied to an object is equal to the mass times the change in velocity of that same object. A real-world application of these formulas is the velocity of a car after brakes are applied. Say a car with a mass of 2,000 kilograms has a velocity of 30 meters per second when the driver applies the brakes for 5 seconds. If the average force applied by the brakes is 1,400 newtons, what is the velocity of the car after the brakes are applied? Writing out our variables, we see that the mass is equal to 2,000 kilograms, the initial velocity of the car is equal to 30 meters per second, the time is 5 seconds, and the force is equal to 1,400 newtons. Because we have the mass and the initial velocity of the car, we can calculate its initial momentum, and because we have the force that the brakes apply and the time for which that force is applied, we can also calculate the impulse force acting on the car to slow its momentum. Using our equation, force times change in time is equal to mass times change in velocity, we can figure out what the final velocity of the car will be. Because we are looking for the final velocity in this problem, isolating velocity on one side of the equation is important to do. We can do this by dividing each side by the mass of the car, leaving us with the change in velocity is equal to force times change in time divided by mass. Substituting in our values for this equation, we get the change in velocity is equal to 1,400 newtons times 5 seconds divided by 2,000 kilograms. 1,400 times 5 is equal to 7,000, divided by 2,000 is equal to 3.5. This means that the change in velocity is equal to 3.5 meters per second. Given our initial velocity and the fact that we know that this initial velocity must decrease after the brakes are applied, we can subtract 3.5 meters per second from 30 meters per second, which gives us our final velocity of 26.5 meters per second. So, the answer to the question is 26.5 meters per second. To show how the change in momentum of the car is equal to the impulse force acting on it, we can also solve those individual equations. Using the equation P equals mv, or momentum is equal to mass times velocity, we can find the initial momentum of the car by multiplying the mass of the car, 2,000 kilograms, by its initial velocity of 30 meters per second, giving us an initial momentum of 60,000 kilograms times meters over seconds, which are the units for momentum. We can then use that same equation to find the final momentum of the car, multiplying the car's 2,000 kilograms by the final velocity of 26.5 meters per second, which leaves us with a final momentum of 53,000 kilograms times meters over seconds. To find the change in momentum of the car, we simply find the difference between the two momentums. 60,000 minus 53,000 is equal to 7,000, so the change in momentum of the car is 7,000 kilogram times meters times seconds. This value should be equal to that of the impulse force acting on the car. Using the equation J equals Ft, where impulse force is equal to force times the time that the force is applied, we can substitute in the values 1400 for the force and 5 for time. The product of these two values is 7,000 newton seconds, which is equal to the 7,000 kilograms times meters over seconds that we found for the change in momentum. This means that the change in momentum of an object after an impulse force is applied is equal to that of the impulse force that was applied to that object. So that is a quick summary of impulse force. Thanks for watching, and bye.